Hi everyone, we're going to sketch the graph of this polynomial given. Let's fill out some information. First, to determine the degree. Since this is not in standard form, we're just going to add up each piece of the factors we have here. So just add that up. This is to the first power, first power, first power. You add up these three, you get n equals 3. Our maximum turning points is n minus 1, which is 3 minus 1, which equals 2. Our end behavior has to do with the degree, which is 3, and the fact that it's negative, and we'll discuss that in just a minute. Our y-intercept is when x is 0. So when x is 0, let's plug in 0, you get negative 0 times 3 times negative 1, and that equals 0. Because this 0 here really basically knocks everything out. Our x-intercepts, or zeros, is when y is 0. So that means when this is 0, so this piece would have to be 0. This factor, that would make that negative 3. And this piece would be 1. So let's plug those in. So 0, 0, 0, negative 3, and 0, 1. We'll discuss the intervals where f of x is negative and f of x is positive after we graph. So let's discuss end behavior. So in our case, our degree is 5, and no, our degree was 3, right? So our degree was 3, and it's negative. So that's odd and negative. So it has this form here. So if I graph that, which is this one right here, that's just y equals negative x cubed. So it looks like that. So when you're talking about end behavior, you're talking about end behavior, you're talking about when you graph the graph we want to graph, where are we starting when we're graphing this from left to right, and where are we ending? So basically we're starting in quadrant 2, which is negative, positive, and we're ending in quadrant 3, which is positive, negative. And that's basically what this part is right here. So we're right here. So let's look at it. As our x tends to large or gets bigger and bigger, our y is getting smaller or going to negative infinity. Or as our x values get smaller and smaller, our y values are getting larger and larger. All right? So that's all that means. And basically we're going to start in quadrant 2 and end in quadrant 4. Quadrant 4. So let's graph this. We're just going to sketch a graph. Y-intercept was 0, 0. We also had zeros at negative 3 and 1. Now all of these had powers of 1. That means at each of these intercepts, it crosses the x-axis. We're also starting in quadrant 2. So when I go down to negative 3, since that's a 1, it means I can cross. So I cross, but I have to come through this x and y intercept. It can cross, and then we're not going to worry about our local min and max here. We're just going to sketch the graph, and then we shoot back down here. Because we can cross everywhere at the x-axis because all of these numbers are odd. So there's your general form. We started based off our end behavior in quadrant 2 and ended in quadrant 4. So let's talk about where our graph of f of x is negative. That means below this line, y equals 0. So it's negative below right through here, So the x values, that would be negative 3 to 0, and also from 1 to infinity. And where is y positive? So our y is positive at two places. Here, from negative infinity to negative 3. And also this little portion here. It's positive above this y equals 0 at 0 to 1. And that's it. Thank you. Have a nice day. Bye-bye.